G'day Trailblazers, my name is Cam. Welcome to the 5th lesson in my Introduction to SQL in Salesforce Marketing Cloud series. In this lesson, we'll be covering some of the string, math, and date functions in SQL and show you how you can use these functions to alter and compare your data in your data extensions. So like the previous lessons in this series, this will be a direct follow-on from lesson number 4, the aggregation and group bys lesson. So if you've not watched that one just yet, then pause the video and go check it out, and then come back here to complete our story of our subscribers in that book event, trying to sum up their data of their books purchased and the total retail value. So at the end of lesson 4, we were having a look at 2 of our customers that we're trying to get some more data for, to pass on to the event team to get them to be invited to the book event. We had a small problem. As we were joining up our data, we couldn't quite get this sum retail price to work properly. And the reason was, we couldn't use our aggregation functions to sum up the correct number of books and their value against their sum total value. The reason for that was because a customer can, of course, buy multiple books, and of course multiple of the same books, in the same invoice. Maybe buying some books for a friend after all. So we had to find a way to sum the total number of books that were purchased and their total retail value. Looking back at our data views here, we can see that our customers to invoice details, and here was our problem. A SKU, which of course is our book, which has that retail price, can be purchased multiple times. A higher quantity, or QTY value, means it may have bought more than one book. So we need to produce the correct total retail value, sum the number of books against their retail price. We don't want their invoice detail price because that is the price they paid at checkout. That could be the retail price, but it could have been the sales price too. And after all, we are trying to find out the total retail value of the books they should have purchased versus the amount they actually spent to find out how many sales they took advantage of. So what we need to do is find a way to use our group by functions in our current selection statement to multiply the quantity of books against the retail price. Well, lucky for us, we can do that in some SQL. So jumping back into our data extension, what we want to try and do is make the sum retail price the correct value. We did have a price here, but it was wrong. So let's jump into our query and try and fix it. Go into our query tube, and let's see what we can do. Now scroll down here to our sum retail price, and currently all we had was the sum retail price as an aggregate. What we need to do though is multiply it by the number of books that were purchased in the invoice detail. So how can we achieve this? Well, for starters, we can change the way our current query is structured by simply changing the way we've got our current inner joins for our invoice detail and books. Just like before, we actually don't need all the fields in these 2 tables. And what's more, we actually need a couple of fields from each table. So we can make some space in our query and do some smart inner queries here. We can say, yes, get our invoices to start with, and then we're going to inner join a nested query. In this nested query, we're going to select some data. What do we need? Well, of course, from our invoice detail table, we're going to need that invoice ID. That's of course a very important field to have. On each invoice ID, we're going to want to get the SKU that was purchased. So we're going to get the SKU against the invoice ID. We also then want to bring in the actual retail price for each book. So retail price, I can navigate through my folders on the side here and find my SQL books. And I can bring in the retail price of that book. Now, of course, this will come from a few different tables. The retail price coming from our SQL books. So from our from statement, we can then say from our invoice details, that's fine. We'll call this one A to start with. And then we're going to inner join on our books. Just like that, and we'll call this one B. Joining these 2 tables together on what fields? Well, of course, on SKU. That's the joining comparison between these 2 tables. So on B is equal to A SKU. So we now have the invoice ID, SKU, and retail price coming through. There's one more thing that we can do here. We actually just want to group up our data based on the count of the quantity of books that were purchased times the retail price. So we can do some smart math here. The retail price is value coming through from the SQL books table, which we've called B. We also want the actual quantity of what was purchased, that's in the invoice detail. So we can say retail price times invoice detail is the A table and the field I believe for quantity was QTY. So we say a.qty. The times symbol here, the wildcard, is a math function. So the retail price times the quantity should be equal to the total retail price. Perfect. So now we have, for each of our invoices and each of our SKUs, we should be able to get the retail price and the quantity put together. Now we're not quite done, unfortunately. We will have to make a couple of small changes here, because our invoice ID coming from our A table, of course, our SKU coming from our A table, we're going to need to join this back into our other invoice table here. And to do that, we're going to call this table B. We're going to be joining what? Well, b.invoiceID joins back onto a.invoiceID. All right. So now, of course, we're not going to need these other fields. We're not going to need the invoice detail or the book. So we've done that math already on the inside. We're going to be bringing back in, though, this inner calculation. We've got invoice ID and SKU. Of course, invoice ID required for this. And the SKU coming back in as total retail price. Now, total retail price is on the B table here. So it's going to be the B, sum of B retail price. There it is, as the sum retail price. With all this done, there's still a group by function here happening, but I think we're missing one more thing. Maybe not, maybe we're looking pretty good. At the moment, let's walk it through one more time before we run the query to make sure it looks okay. We've changed nothing up above, all we've changed is this last inner join. We've made it quite complex, so let's step through it. We are joining in our customer ID and the sum of the retail price. And the retail price is going to be grouped on the customer ID, so we've got that group by applying here. We're joining in from the invoices, join the invoices on some invoice details and books. We didn't just want to join in the invoice details and books as those tables are by themselves, because we actually need the detail of the both of them put together. And to achieve that, we brought those two tables together and did some math here. The retail price times the quantity for each SKU in each invoice. So once we've done that, we should have the total retail price for each SKU in each invoice, which has then been applied back to our invoices. Of course, a customer has multiple invoices. So we then sum up all those values all together to hopefully get the customer's total sum retail price. So with that all done, let's go next and see what happens. So we'll go finish on our query, and then we can go save and run once for our automation. So our query is just finished. We can jump back into our data extension, and we did have that sum retail price of $56, about $275. So let's refresh it and see what it looks like now. We still have, of course, our two rows, good. Let's see what our final result is. How much did they actually spend versus their total retail approximate spend? Interesting. So it looks like customer one, Kathleen, was on $56 of total spend, and of course their sum of retail was also just $56. But our second customer, Jennifer, she was able to secure a bit of a discount. She only paid about $440, where the total retail price of those books was more like $465. That's a good $25 discount during those few invoices. Well done to Jennifer. So multiplying the quantity of books and the average retail price of those books together is a great example of one of those math functions we can use in SQL. But there are loads more functions at your disposal. Let's jump in down to a new query and I'll show you what I mean. We'll make a new query activity. We'll go choose, and as before, we'll choose to create a new activity. This one we'll call our query number 3. We'll go next, and let's have a look at what our syntax could look like. Now we do have access to some really cool functions like our string functions. So if I jump down into one of my data extensions here, and let's use my authors. We'll start with this one. So we could say we're going to select some data from our authors. Now what do we have in our authors? Well, I'm pretty sure we have our author name. So for example, in our authors, we can bring in their first name. And just in case that first name data is not the correct case in SQL, it might all be in uppercase. We instead want it to be in lowercase. Or perhaps it is in lowercase and wants to be in uppercase. Well, lucky for us, just like in MScript and SQL and many other programming languages, we can use things like our upper and lowercase functions. So I could say upper to uppercase that first name function as fname. We can check that out. We have an uppercase function. We can also lowercase using lower to lowercase that value of first name. We don't just have to use cases though, we can also check more things about this data. So very similar again to your Excel and your M script, you have other functions like the length function. We can check to see how many characters long the author's first name is. So we could say for length, it's len, for length. What is the length of a customer's first name, or the author's first name? We could also say, maybe our data has a leading space or a trailing space. Maybe our data is not that clean and needs to be trimmed of the front and the back spaces. Well again, lucky for us, we can use our trim function. Before we start counting our first name, we could say trim, to trim the front and back of that first name in case there is leading or trailing spaces. Now, lucky for us though, that trim function does not trim spaces from the middle of someone's name, just from the top and tail. Now additionally, to our upper and lowercase length and trim, we can also use some great string modification functions, like our substring. So also, like in Excel, we can jump into our first name and say, I just want to get the initial, just the first character of my author's first name, and I'll make that my initial. Well, to do this, I can use the substring. Now for substring, I specify the value to query, so in this case it's the first name, my starting position, which will be character number 1, and for how many characters do I want to query? Well, for 1 character. This will get me the initial of my customer's first name. Now I could then choose to uppercase that initial, so I could then say upper, and uppercase that initial. Now good. But additionally, I may have characters in my customer's name or other details that I don't want to keep. For example, it's very common with mobile phone numbers to have the full international dialing code at the start of that phone number. For example, in Australia, it's +61. So, for example, I may have someone's phone number that is, in text here, +61 and something else. Now I don't want that plus at the front, that's not going to help me in Mobile Connect. So I could say I want to replace. Just like this. I want to replace what? Well, with my replace function, I first specify the text, that's my text. I then say, what do I want to find? I want to find that plus symbol and remove it. So what am I going to replace that plus symbol with? Well, replace it with nothing. There we are. That will simply trim away that plus symbol for me to give me a clean mobile. But it's not just string functions we have access to inside of our SQL. Jumping back to my W3 Schools documentation, I can go to my SQL Learning page here, and I can see all my syntax and all the things we've talked about so far in this course. All my joins, all my unions, some really great stuff. But if I keep scrolling down, I'll get to my references, and in particular, I want my SQL Server functions. I click on that, I see all the functions I can use, and we just covered some of those string functions, and you'll recognize some of these other ones here too. For example, the char function, like you can do in AMP script. I can see here, there is our lower. I can also see my length. I can also use my trim and my string replace and my substring and so many more string functions. If I keep scrolling, I'll find my numeric functions. Now again, for math in SQL, I can use shorthand. So just like we did with those 2 values in our earlier example, I can have 2 starting numeric values. So for example, 1 and 1, and to add them together, I just say plus. So 1 plus 1 should equal 2. There we are. I can also use the other math shorthand, such as minus to subtract, the star to multiply, and the slash to divide. But for more complex mathematical functions, again, and jumping back to my documentation, I've got things here like the ceiling or the floor, rounding up to or down to the nearest number. I can use things like my power, or I can use things like my sin, cos, and tan, square root or otherwise, to do more complex maths functions. In addition to my math functions, I've also got, of course, my date functions. Now here's where the real power comes in. If you have some date structures inside of your data, jumping back into my code here, I can see, for example, my invoice date and my join date are both date type data types. Using those types of data, I can access these date type functions. I can pull information such as the date part. I can pull out the day, the month, or the year. So for example, in this one, the date part of this function here should be the year of 2017. I could pull out the month or the day and retrieve those values. I can then take those values and get other values from them. For example, I want to get the actual day of the year that it is. What day is the 25th of the 8th, 2017? I can pull that information out by formatting my date parts. This again, going back to our lesson number 1 where we talked about data types, is so crucially important. If we have our date and data types correct, we can then access these additional functions. So it allows you to do things like finding out what the average day is for purchasing books inside your bookstore. You can find out what week of the year or what day of the month, and other things you can only do if a date is stored as an actual date string, an actual date value, and not as a number or a string. And that brings us to our final set of functions, our advanced functions. Now these do have a lot more complex use cases, but it's worth knowing what they can do just so you know exactly what's at your disposal in problem solving for SQL. Now the first and most important function in this group here, advanced functions, is definitely going to be the cast function. Now the cast function in SQL allows you to change the data type. As you can see here, converts a value into a specified data type. An example given here is casting a boolean, a decimal value, into an int, into a whole number. You can see there's a lot more that we can do as well. For example, casting a decimal number into a varchar, into a string. Or if I have a date stored as a string, I can change it to a datetime value. How good. So let's pick this up and we can try it for ourselves back in our SQL function. Let's go and change our cast date time as new date. And so now this string, which could be a real string, which we could have stored in one of our feedback comments or otherwise, we can now convert into an actual datetime value. Now that it's a datetime value like I just covered, we can go back and use those date functions. So I could say, well, we've got the date now, let's add things to it. We could use a date add function to add 1 year to that date. So let's try it out. We'll say date add, and we'll add what? Well, let's add year, and we'll add what? Let's say 5 years to that value. Oops, and of course it's not year in quotes, it's year as a whole value. There it is. Perfect. So now we've added 5 years to a correct date time formatted date of a date string. So again, I can't stress enough just how many functions you have access to inside of SQL, and it's going to be difficult to memorize them all. So if you do run into problems and you are trying to solve something in SQL, the first and best advice I can give to you is try to normalize the problem that you've got to make your question of how to solve it as generic as possible. Don't try and say, how do I join an author of a book's first name and last name? Say something like, how do I join 2 strings together? By Googling something like that, or going to Stack Exchange, you'll find a lot more responses and a lot more examples of the functions that you can use in SQL. The other important thing is that the SQL version that's used by Marketing Cloud is going to be your SQL server, your SQL server functions, not MySQL and no other SQL variants. If in case you do run into problems with a function you're trying to use, a great example is in the string functions, it's the length function. Because you'll find that the len function is the correct way of saying it for the SQL server, but for other SQL languages, it might actually be length as the full name. So if you do have that problem, where you found a function example on Stack Exchange or otherwise, that's not quite working inside of your SQL inside Marketing Cloud, Google it, and you may find that you've got the wrong SQL syntax. You can always jump back into here as well on W3 Schools and find your own function reference and look for a similar reading one here in this list. So as you can see, back on the SQL Server functions, there are heaps and heaps of functions and descriptions here for you to go through and read for yourself. I won't waste your time now going through these one by one because there are loads of great functions, but you're probably not going to use them until you have a really good use case. So with that, I'll close out this lesson, number 5 of our functions in SQL. If you did have a function you're curious about, I'd like to know how it works, then please let me know in the description below. And don't forget to leave the video a big thumbs up if you enjoyed the content so far. And stay tuned for lesson number 6 as we go through one of my favorite functions in SQL, the case function. But until then, happy learning in SQL, Make sure that you are subscribed to the channel so that you can be notified once the next lesson comes out.